So, you're scrolling through your phone. Maybe you're watching a video of a cat playing a tiny piano. Or perhaps you're video chatting with your cousin who lives halfway across the world. You send a quick email, upload a picture of your lunch, and then maybe lose an hour falling down a wiki hole about the history of cheese. All of these things, from the silly to the essential, are powered by this amazing global network we call the Internet. It connects billions of us, allowing us to share, learn, and communicate in ways that were pure science fiction just a few decades ago. It's a vast public space for commerce, entertainment, and connection. The internet you use every day is a bit like a massive, sprawling city. It has superhighways, but it also has countless smaller streets, intersections, and even the occasional traffic jam. When you send a message or stream a movie, your data is broken into little packets. These packets travel from server to server, navigating this digital city to reach their destination. This system is designed to be incredibly resilient and open to everyone. It's built for general-purpose use, handling everything from online banking to streaming the latest blockbuster movie, making it a foundational part of modern life for just about everybody on the planet. This public internet is a commercial marvel. It's run by thousands of different internet service providers, or ISPs, all over the world. They all agree to connect their networks together to form the single global internet we know. This makes it a shared resource, a network of networks that has to handle an unbelievable amount of traffic from every corner of the globe. Because it serves so many different people doing so many different things, its performance can sometimes be unpredictable. Think about when a popular show drops on a streaming service and everything suddenly feels a little slower. That's digital rush hour. This shared commercial nature is the internet's greatest strength and also a key limitation. It's a jack-of-all-trades network. It's pretty good at everything, but it's not necessarily specialized for any one thing. It has to balance the needs of a gamer requiring low latency, with a company backing up massive files, and a student just trying to watch a lecture. This balancing act is what defines our daily experience online. But what if you needed a network that wasn't just pretty good, but was specifically designed for massive, time-sensitive, and incredibly complex tasks? Well, for that, you'd need something else entirely. Now, imagine a completely separate, private highway system. It has hundreds of lanes, no traffic jams, and is built only for specialized, high-performance vehicles. That's a pretty good way to think about Internet2. It's not a replacement for the internet, and it's not the next version of the internet. It's a parallel network, a distinct and separate entity. Internet2 is a United States-based, non-profit consortium led by members from the research and education communities, including universities, government agencies, and industry partners. Its whole purpose is to provide a super-fast, reliable, and advanced network for their specific needs. So who gets to drive on this digital superhighway? Well, not everyone. Access to Internet2 is limited to its member institutions. We're talking about major research universities, government labs like NASA, and other organizations that are pushing the boundaries of science and technology. It's a network built by and for the research and education community. This exclusivity is key to its function. By keeping general public and commercial traffic off its lines, Internet2 can guarantee incredible speeds and reliability that would be impossible on the public internet. It's a dedicated tool for a dedicated group of users. Let's talk about speed because the difference is just staggering. Your home internet connection might be 100 megabits per second, which is great for streaming 4K video. The backbone of the Internet2 network, on the other hand, operates at speeds of 100 gigabits per second, and is moving towards 400 Gbps and even 800 Gbps. That's thousands of times faster. To put that in perspective, downloading a full high-definition movie on a fast home connection might take a few minutes. On Internet2, you could download hundreds of them in the same amount of time. It's less of a highway and more like teleportation for data. This incredible speed isn't just for showing off. It's a fundamental requirement for the kind of work being done on the network. The public internet is designed to move small to medium-sized chunks of data for billions of users. Internet2 is designed to move colossal data sets for a much smaller number of users, but those users are doing things that generate more data in an hour than most of us create in a lifetime. This network isn't just faster, it's built on a different scale for a completely different purpose, serving the pioneers of science and discovery. So, what do you do with a network that's thousands of times faster than the regular internet? You do science that would otherwise be impossible. For example, think about the Large Hadron Collider in Switzerland. It generates a petabyte of data, that's 1,000,000 gigabytes every single day, Scientists all over the world need to access and analyze that data. Trying to send it over the public internet would be like trying to empty a lake with a teaspoon. But with Internet2 and its global partners, researchers at a university in Chicago can access and manipulate that data almost instantly, collaborating in real time with colleagues in Geneva. It's not just about physics either. Medical researchers use Internet2 to share enormous files from genome sequencing or high-resolution MRI scans. This allows doctors and scientists at different hospitals and universities to collaborate on diagnosing rare diseases or developing new treatments without having to physically ship hard drives back and forth. Astronomers use it to connect massive radio telescopes located on different continents, effectively creating a single, planet-sized telescope that can capture incredibly detailed images of black holes and distant galaxies. These projects depend on moving massive amounts of data reliably and quickly. Internet2 also enables new forms of education and artistic collaboration. Imagine a music student in New York taking a live masterclass with a world-renowned cellist in Tokyo. On the regular internet, the time lag or latency would make it impossible to play together in sync. But the high-performance connections of Internet2 can reduce that lag to milliseconds, allowing for seamless, real-time musical collaboration across oceans. Similarly, student surgeons can practice procedures using high-fidelity virtual reality simulators that are connected to experts at another institution, receiving immediate feedback as if they were in the same room. These examples show that Internet2 is more than just a faster pipe. It's an advanced services platform. It provides a testbed for new networking technologies, security protocols, and applications that are far too demanding for the commercial internet. It's a sandbox where the future of networking is being built and tested. The network allows for the creation of private dedicated circuits for specific experiments, guaranteeing performance in a way the public internet never could. It is a purpose-built environment for discovery, designed to remove the limits of distance and data size from the process of innovation. So why don't we all just switch over to Internet2? The main reason is its purpose and cost. Internet2 is a specialized tool, not a public utility. It's funded by its member institutions for the specific goal of advancing research and education. Rolling it out to every home would be incredibly expensive and frankly, unnecessary for most of what we do online. Your email and cat videos don't need a 100 gigabit per second connection. The commercial internet is built for broad access and affordability, while Internet2 is built for peak performance, and those are two very different engineering challenges. However, that doesn't mean you'll never benefit from it. Many technologies that are now common on the public internet were first developed and tested in high-performance networking environments like Internet2. Think of it as the Formula One of the networking world. The cutting-edge technologies developed for race cars like better engines, aerodynamics, and safety features eventually trickle down and find their way into the family cars we drive every day. In the same way, protocols and software created to manage the massive data flows on Internet2 can inform the development of the next generation of the commercial internet. The main differences are clear. The internet is a global commercial network open to everyone, a jack-of-all-trades designed for general use. Internet2 is a private, non-profit, high-performance network for a select community of researchers and educators in the United States, a specialized tool for massive data-intensive tasks. The internet has billions of users and variable speeds, while Internet2 has a much smaller user base but offers mind-bogglingly fast and reliable connections. One is a bustling public square, the other is a state-of-the-art laboratory. Ultimately, both networks are vitally important. The public internet connects our world, democratizes information, and powers our daily digital lives. Internet2, on the other hand, provides the infrastructure for discoveries that can change that world. It allows humanity's brightest minds to collaborate without limits, solving some of the biggest challenges we face in medicine, climate science, and our understanding of the universe. They are two different networks, built for two different jobs, but together they help create a more connected and knowledgeable future for all of us.